Let's look at some theoretical probability examples. So a six-sided die is rolled once. Find the probability of rolling, and then we have multiple different things that we're going to be looking for. So in this case, the sample space, all of the different possible options are 1, 2, 3, 4, 5, or 6. Right? Those are the different things that we could get happen when we roll a six-sided die. So if I want the probability of rolling a 3, there's only one way that could actually happen, if I got that 3. But there were 6 total possible options, so I would have that 1/6. Now if we think about an odd number with this part B, we have that sample space 1, 2, 3, 4, 5, and 6. So remember, our odd numbers cannot be divided by 2, so they're 1, 3, and 5. So that gives us the fraction 3/6. Now you're going to see when you're asked to answer as in fraction form, you're going to be asked to simplify it. So you may know that 3/6 is 1/2, but if you're struggling to simplify, you can use your calculator to help you out. So if I use this Desmos calculator, I'm going to type 3 divided by 6, and notice it gives me 0.5. But if I hit the fraction over on that right-hand side right next to the 0.5, it gives me the fraction in simplified form, that 1/2. So you can use your calculator to simplify the fractions for you. If we look at part C, they were asking us here to find the probability of rolling a number less than 4. So remember, when we're talking about less than, it has to be below that number. So it could be the numbers 1, 2, or 3. So there's 3 possible things we want out of those 6 total things, which once again gives us that probability of 1/2. If we think about our sample space again, but this time in relation to part D, where they said that we want the probability of getting a number greater than 0. Well, all of them are greater than 0. So there's 6 possible things I would want out of 6. Now when we do that division, 6 divided by 6, it actually gives us that whole number 1. So when we're asked to simplify it, we want to give that whole number answer if we can. And then for part E, they asked us for a number less than 0. So that would be numbers like -1, -2, right? All those numbers less than 0. Well, none of them are less than 0. So there's 0 ways that could work out of the 6 total ways. And same thing, I can divide that. If I do 0 divided by 6, that's going to give me 0 as my answer. If we look at this last example, they ask us for the probability of not rolling a 4. So there's 2 different ways we could think through this. We could use the sample space and think through it that way. The probability of not rolling a 4, well, we want everything except a 4. So there's 1, 2, 3, 4, 5 different things we want out of the 6 total things. We could also choose to use that definition of a complement. So we could say if we're looking for the probability of not rolling a 4, that's 1 minus the probability of rolling a 4. Well, the probability of rolling a 4 is 1 out of 6, because we can only get the 4 one way if we get the 4, and there's 6 total ways. There are 6 total options here. So if I do 1 minus 1/6, right, that gives me that decimal answer, but if I hit the fraction button, it gives me that same answer we got just by looking at the sample space 5/6. So let's look at another example, but here we're looking at what happens when a single die is rolled twice. So if you think about games where you have to roll 2 die, like Monopoly, right? That's kind of the situation we're thinking about here, but instead of rolling 2 die at the same time, we're going to roll 1 die twice. They give us this table of values, right? So if we focus in on this 2, 3, it's telling us that we got a 2 on the first roll and a 3 on the second roll. That's how we can read this table. So if we look at This first option, part A, they're telling us we're trying to find the probability of getting two numbers whose sum is 7. So if I'm looking through this table, 6 and 1 adds to 7. So does 5 and 2, and 4 and 3, and 3 and 4, and 5 and 6, and 1 and 6. So if I look at what I have highlighted, there's 6 different ways to get 7. And there's 36 total different outcomes in there. So if I simplify that fraction, 6 divided by 36 is 1/6. If we look at part B, they ask us about the probability of getting doubles. Doubles are when we get the same number twice. So like 1 and 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5, and 6 and 6. So once again, there's 6 different ways we could get it out of those 36 possible outcomes, which gives us 1/6. Now let's look at part C, where they're asking us whose sum does not exceed 10. So if we're thinking about all the different things that do not exceed 10, right, the sum doesn't exceed 10, that means it's 10 or lower. So it could be 10 or 9 or 8 or 7 or 6 or 5 or 4 or 3 or 2. Now technically it could be lower, but the lowest thing that we can roll here is a 2 if we're rolling 2 die. The issue is if I go through and try to actually count all these, I'm going to be counting a lot of different things. So I'm going to use that definition of that word not, that complement. So remember, the probability that it does not exceed 10 is 1 minus the probability that it does exceed 10, because that's going to be a lot fewer things to count. So if I'm looking for what does exceed 10, well, 6 plus 6 gives me 12, and 6 plus 5 and 5 plus 6 each give me 11. Then everything else gives me either 10 or lower. So there's 3 things that exceed 10 out of those 36 total different things. So if I do 1, I need to type it in the calculator. If I do 1 minus 3/36, that's going to give me 11/12. Last but not least, let's look at this part D. They're asking us to find the probability of the sum that is not more than 1. So if we think about that not more than 1, right, that means that it's lower than 1. So we could be numbers like 1, right, because not more than 1 could actually be 1 itself. Could be 0, could be negative numbers, right, could have some decimals thrown in there. But if we look back up at this table, there's nothing that's that low. 2 is the lowest that we can roll, so it's impossible. So the probability of that occurring is 0.